Welcome to the NSX Advanced Load Balancer Operation Workshop video series. My name is Sean, and in this series, I'm going to be covering NSX ALB Understanding Virtual Services. So let's first look at the topology I'll be using. I'm going to be leveraging the HOL labs. So if you wanted to follow along, or maybe even just spin up an environment to sort of play around with, or use the lab guide that's provided in the HOL lab. The URLs below under labs.hol.vmware.com. I gave the full path, but you can also just search for 2137 and it'll bring you to our different HOL labs. I put the password on the side here, so if you need a quick reference, it's there. And this is our topology. You see we have two sites. I'm only going to be leveraging the one site, so only the AVI controller 01A. And in this, I have some web servers I'll be using, and I'll provide those IPs as I go. So during this video series, these are the topics that I'll be covering. So all these topics eventually will be covered. In this specific video, I'm only going to be focusing on the ones in blue. So we'll be doing a virtual service introduction. I'll do a demo with a basic virtual service, and we'll cover application profiles. Application profiles at a high level is what defines your application. So in this case, I'm going to be focusing on the HTTP application, but further down you see I cover layer 4 and DNS application profiles. So it'll all be covered in the end. So let's jump right into virtual service introduction. So I just want to level set. I know some of you might know load balancing, but for any new users, I just want to make sure we're all on the same page. So what is a virtual service? Well, a virtual service is a primary software construct that will group together all the software components needed to load balance client traffic. In our case, it'll also provide reporting functionality. So looking at this diagram, we see a client is going to establish a connection to a virtual service. So that virtual service is going to have an IP, port, listener, network profile, and app profile at a very minimum. There's some other minimums, and that's on the next slide, but at a very minimum. And this virtual service is actually placed on a service engine, and the service engine knows how to reach the backend pools. So at a high level, this is what our traffic flows will look like, and I'll show that in our demo at the end as well. So here are the components of our virtual service. At a very basic configuration, we'll have a name for that virtual service. We'll have at least one IP address as well as a listening port. So in my demo, I'll be using the listening port of 80 because that's the port for HTTP traffic. We'll also have an application type or profile. I'll touch on this more as we go through the demo. One network type or profile, so whether we're talking TCP or UDP. And then it's not required, but you can configure a pool. In a lot of cases, you'll always have a default pool, but it's not required, and I'll show that in the demo as well. Now, what is a pool? Well, that's the software construct that will group together all the software components needed to understand where to direct client traffic to. So how do we reach those backend servers? How do we load balance those backend servers? How do we know the backend servers are even online still? So these, if you look at the pool line, we see I'll have a server list. So those are the backend server IPs or host names. And then we have algorithm. So how are we load balancing between those backend servers? Health monitoring to determine which one's up and online. And then we have persistence profile as well, if we need to maintain that connection to the same backend server. So I think it's about time we just jump right into the demo and start taking a look. So if you're going to use the HOL lab 2137, 01, 02, or 03, you'll end up on this page once the lab is deployed. So on this page at the bottom, you'll have a Google Chrome, or you can click the Google Chrome here. So once you click that, you won't end up here. You'll end up on a vSphere page. But to get here, all you need to do is go to region A. You're going to select AVI Vantage Controller A. And when you select this, it'll bring you to a password prompt screen. Just put in the passwords we saw at the beginning of this lecture. Now, let's dive right into this lecture. So the first thing you'll see when you log into the controller, we have 3 virtual services already up and running and waiting for you to explore or if you want to create your own, you can do that as well. But just to give a rough idea on what these are just demo applications that we have already configured, just so you can look and see. The main one I want to look at first is the DNS-VS. So when I create virtual services, I'm using this DNS-VS to resolve the names of the FQDNs that I configure on this virtual service. So if I do an NS lookup or a dig on the FQDN I configure under a virtual service, it'll hit this DNS-VS and resolve it. So this is just for this lab environment, and this is just a tip for you if you want to play with actual names instead of IP addresses. So let's get right to it. Let's build a basic setup for a virtual service. So looking at this, it looks pretty simple. There's a small page and it goes to save right away. So I mean, it doesn't look too hard. So we're going to name our first one Avi Networks. We have application type. So the application type is going to define our application, and we can further tweak this. So I'll show that. I just want to configure it, and then we'll jump into the more detailed analysis. We have the ability to set our service port, and we can only set one in this case. So I'm going to leave it at 80 because my application is HTTP. Now, if I was to choose a different application type, we see some more fields appear. So let's look at an HTTPS example. So once I select HTTPS, it changes my service port to 443, but on top of that, I get a certificate view as well. So this is a more advanced configuration, but you see we can set an HTTPS application as well in the basic setup. But for simplicity's sake, let's stick to the HTTP example. So for my IP address, I'm going to auto-allocate the IP address. In this lab environment, we are actually using the IPAM management that's done within the NSX ALB. So what that means is I've created an IPAM profile, and then I've set up the networks associated to that IPAM profile. So the NSX ALB knows that only certain networks will be used for virtual service placement for the IP address. So if I go here, I'm going to select this network. Once I select this network, I should only see one IP, and it's the 192.168.130/24. So this is what I've configured in my IPAM profile and under my networks. So once I save this configuration, I should automatically get an IP. So here's the application domain name, and this is what I should see on that DNS-VS, and I should be able to resolve this after I save the configuration. But first, maybe I want some pool members. So this is where I was saying it's not necessarily required to configure pool members. I could just click save and the configuration would save with no errors. But in my example, I want to demonstrate deploying some pool members as well. So I could put server IPs here. I could put whatever the IP of a server is. But what I'm going to do is I'm going to select servers by network. So when I select servers by network, I get this drop down. And I see a range of different objects, different identities. So let's click this one. And it populates with virtual machines. So how does this happen? In this lab, we're using a vCenter cloud integration. So our cloud connector is talking to vCenter, and our cloud connector is learning a lot about that vCenter. One of the things it's learning about the vCenter is different port group names. So all these are the different port group names in the vCenter cloud. So once I select this, I get virtual machines. This is another thing our cloud connector is learning. It's learning what virtual machines and what their IP addresses are for that vCenter cloud or vCenter environment. So I can now select these web servers or virtual machines to use in my pool configuration. So once I click add servers, I should now have the servers, and here they are. One thing I want to note though is how can I configure the backend port for these servers, right? I can configure the front end port for the virtual service, but I can't configure the backend port. And this kind of comes to our basic configuration, our basic setup. So there are some limitations to that basic setup. So I'm suspecting my virtual service might not work right away because I don't think these pool members are listening on port 80 or whatever the default port gets configured for that backend pool. So let's save this and see what happens. So this is where we see that the pools belonging to this virtual service are now down. So that makes me think that my pool actually is not listening on this specific port. So let's go back to the pool. I just want to fix the port. I don't want to stay on this topic too long. I just want to correct that port, and then we'll dive into all these details later. But let's first change this default port. Let's make sure my virtual service comes up. So the pool has come up, and great. Now we see our virtual service is happy. It's yellow, but that at least we know it's up and online. So what I want to do now is look at the more advanced configuration. So if I edit this, we can see there's a lot of different details here. And not only that, we have more tabs. So that basic configuration, it looks like it configured quite a few defaults. And even for the pool, there was quite a few defaults. Like we saw that there was a lot of different fields on the pool as well. And we'll go in the more advanced configuration in the next video. But I just want to highlight that there's a lot of defaults that are taken in when we do basic configuration. So I think it's good to test our virtual service too. And I'm going to test on the domain name. So the avnetworks.region01a.corp.local. So let's do that now. avnetworks.region01a.corp.local. And great, the application's working. How do we know the application is actually being hit? Let's check the logs. Yeah, so looking here, it looks like some traffic reached our web application and we got a response. So this is a good sign. We're getting active traffic and they're flagged as non-significant. Non-significant mean it's good traffic. So now what we want to do is dive deeper into one of the concepts, being that the application profile. So here we have our application profile, and as I said, this further defines our application. Where can I find the application profiles? Well, it's under templates and applications. And here we see a bunch of different application profiles. So these are the system packaged application profiles. So for HTTP, we have a couple. The main ones being system HTTP, which is our, there's not as many security settings, and there are some defaults that we recommend, but not every use case requires them. And then we have our system secure HTTP. So this one generally is used for HTTPS traffic, or if we want to make sure that it's always going to be HTTPS. So now let's go through what's in these application profiles. So I'm going to focus mostly on HTTP for this video. Then in one of the next videos, we're going to be touching on the DNS and layer 4 application profiles further. But for HTTP, we'll go through these topics now. So connection multiplex. A lot of different load balancing technologies have this. What it is in a normal operation, a load balancer would open a new request to the backend servers when any connection comes in. So it would be always a new connection, and then close that connection to the backend server when everything's complete. So what if this is enabled does is it'll allow the ability for backend connections to be reused by multiple clients. So on the backend server, we would only see a couple open connections. It wouldn't be as many connections from our load balancer to those backend servers, which reduce the amount of resources required for those backend servers for the opening and closing of these connections. We have preserved client IP. So since we're proxying connections to backend servers, we're also doing a source NAT of our service engine IP and communicating to those backend servers. So what preserved client IP would do is it would keep that client IP instead of using the SE IP. And there is a prerequisite for this one to be enabled, and it's just so IP routing is enabled for the SE group being used. So we would have IP routing enabled, and we would preserve that client IP. We also have our XFF or XForward4 header. As you can see below, we can change the name of this. But what this is a header insert, which will add and send to the backend server. And in that header insert, it'll have the client IP. So we can give it a different name if required, or just keep the standard one. This one's normally the default for web applications to look for. We can also enable WebSockets proxy, and this will allow the client to request to upgrade the connection to WebSockets. We have some security features as well. So since I'm looking at the HTTP profile, the system standard one, they're all disabled. If you want to enable these, I would recommend making a new profile or using the system secure. With that, you could modify them as required. If you're editing this one, you might be editing it for other applications that might use the default. Because remember, in the basic configuration, it took the default of this system HTTP profile. So if anyone else is using that basic configuration, they auto get assigned this. So if you change any of these settings, it could affect other applications. So reset connections on HTTP request for SSL port. Well, we want the request to be HTTPS. So if an HTTP request is coming on the SSL port, we'll just reset that connection. SSL everywhere is pretty handy because you could just enable all these features in one click. And these features help add a little more security to your HTTPS connections. So HTTP to HTTPS redirect will always redirect any HTTP requests coming on that HTTP port to HTTPS. Secure cookies. So our backend servers are likely sending cookies not secure. This could be when the backend servers are communicating on an HTTP port instead of HTTPS, so cookies aren't being tagged as secure by them. HTTP strict transport security. This one will indicate that connections to this virtual service should be HTTPS. And to touch on that too, if you're not sure what any of these mean, what you could do is look at this neat little tooltip, and it'll give you a rough idea on what this does. Same for HTTP only cookies. So mark HTTP cookies as HTTP only. This will help mitigate cross-site scripting attacks, as browsers will not allow these cookies to be read by third parties, such as JavaScript. So if you're ever, it's hard to memorize all these, even for me. So if you're ever looking for a quick way to figure out what they do, that tooltip helps. We have our rewrite server redirects to HTTPS. So our backend servers, if they're talking HTTP and they send a redirect, it might be HTTP redirect, not an HTTP redirect. So in the location, it'll say HTTP and then where you're sending you. So maybe we want that to be translated to HTTPS. So this will do that for you. And then our X-forwarded proto, this just tells the backend server whether it was an HTTP or HTTPS connection that was established on the front end. We have our client SSL certificate validation. So this is where mutual TLS comes in, and we can leverage a PKI profile. We have 3 different ways to do this, none being disabled. Request being it's not required to come in with a client cert, but if you do, we can validate it. And require, we always require a client cert, or else we won't accept that connection. I'll leave it at none. Then coming to compression. So what this compression does, it'll enable HTTP gzip compression for responses to clients, which help reduce the size of the data. Once we enable this, we can use auto, which the NSX ALB will determine the optimal settings, or set custom, and this will allow the administrator to specify any specific filters just for some granular control. What are these filters? Well, the filters could be on IP address or user agents coming in, so maybe mobile agents or specific browsers. So coming back a little bit, we have this remove accept encoding header. So what this is this will remove the header, so the backend server will not compress responses. It'll leave it to the NSX ALB instead. So we'll remove this header, send the request to the backend server. Backend server will send it back to the NSX ALB, and we'll compress that data. The other thing is the compressible content types. So what this is, it'll help us determine which types can be compressed. And if we click edit on here, we'll get an idea on what this looks like. So these are the different types that we'll compress. And what this is it's a string group. So you can create custom string groups for what you want to compress. So this one's just an example that you can look at and get an idea on how to formulate this. But you can create your own. You don't have to use this one. If you use this one, you can also modify it. Totally up to you. But I would recommend, instead of modifying a custom default, just create a new one and leverage the new one. I'm going to disable this one and go to caching. So when I jump to caching, it's also disabled by default. When I enable it, we get a bunch of different boxes. So what is caching? Caching, the NSX ALB will cache content for enabling faster page load times for clients. And this will help reduce the load on those backend servers. So let's go through a bunch of these different fields. So Xcache, this is information that will indicate to the client that you're receiving cached data. The age header is the duration to cache the content. So if the object is set to cache for 10 minutes and it has been cached for, say, 5 minutes, the client will know to only cache it for 5 more minutes. Date header. So this is the date that will make the client aware when an object was originally sent by the backend server to be cached to the NSX ALB. We have this aggressive setting, so this cache can be enabled or disabled without the cache control headers. We can also specify what is cacheable by how big they are. So if it's a very large image, maybe we would reduce the max bytes and just not cache those large images. Or maybe you want to cache those large images, so you would set it up to the max size of those images. You can set a default cache expire timer, just in case those backend servers don't send you one. But if those backend servers do send you one, then you'd use that instead. You also have this heuristic cache expire time. So what this is if the backend server sends an if modified since header, the NSX ALB will use this to calculate an expiration. And this is only if a cache control header doesn't already exist. Now further, we can cache based on URI query arguments. And what this means, match a specific URI query. And we can specify URI queries that we don't want to cache for as well. So this is where you could set up a custom string group for that. And then the other thing is we can specify different cache types. So here's an example of some types we might want to cache. So image, text.css, JavaScript. And then we can set alternatively what we don't want to cache. So this is what we would cache, and this would be what we don't want to cache. And again, it's a string group. So let's disable this and jump to DDoS. So now DDoS, similarly, it has a lot to it. So let's get through all this, and then after that, we'll jump to some analytics and view our basic virtual service more in depth. So for DDoS, we have our client header timeout. This is the time to wait for client headers. We have our HTTP keep alive timeout. So this will be the max time for HTTP 1.0 or 1.1 connections to be idle. We have our client body timeout, time client takes to send an HTTP body. We have our post accept timeout, time to wait for the first byte of a request for the post. After that first byte, we jump back to the client header timeout. We have our HTTP sizing settings as well. So the max size for a client body. We also have some sizing for our header field sizes and complete header size. So this one is for the entire header that we receive from the client, while this one is for each individual header being received by the client. So these two kind of work in conjunction. As your header fields grow in size, maybe you'll have to increase the complete header size as well. We have a send keep alive. So this will send the HTTP keep alive header to the client. And once we click this, we could use this in conjunction. And I don't remember this one off by heart, so I'm going to use the tooltip. So use keep alive header timeout sent by application instead of sending the HTTP keep alive timeout. So we have our HTTP keep alive timeout. So instead we'll use the keep alive header instead of that timeout. So that's good to know. We can allow header names with dot or periods. So in some cases this is required. And then we have our body buffering. And then we have our enable request body buffering. So this is, I've used it mainly for post requests. Further down, we can set some rate limiting as well. So we could add a new rate limiter. The one that you see here is a rate limit connections from a client. So from a specific client IP, we can rate limit the connections. And this one's set to report only. We have different options, so we can drop SYN packets or we can TCP reset. We have many other options here. Some of the options could be related to HTTP headers or cookies. And those options could change. So to sum it up, there is a lot to an application profile, and depending on your use case, you may have to enable, disable, or tweak these. And this is where I recommend, if you're tweaking anything, maybe do a custom application profile. And what I mean by that is you would click create, and you would just create your own custom application profile and set whatever features you need. Great. So we've gone over the HTTP application profile. We've created a basic virtual service. In the last bit, I want to touch on the logs that we see when I navigate to this web page. So when I navigate to this web page, I should see some logs on the virtual service. So I'm going to go to the virtual service. I'm going to click logs. And I just want to understand what's happening when I reach that virtual service. So let's click this log. So here we can see me being the client, 110.10 is talking to this virtual service .93 on port 80. And then the service engine is using its IP to establish a connection to the backend pool. And that pool member is K8's worker 02A. And this is the port I'm talking on. So we can see that full flow. We can also see the round trip time. So this is the client round trip time and server round trip time. So we get a full idea on how quickly that response is happening. And further, we can see information about the browser and other details pertaining to that connection. So we will dive into troubleshooting and looking at these logs in more detail in the troubleshooting session. But I just want to give an overview on what to expect and what the basic logs and how to validate basic traffic. I hope this information was valuable, and I recommend you spin up an HOL lab and explore for yourself. There's an HOL lab guide you can follow, or you can go through this video and follow the same steps I have. So I look forward to our next session. The next session will be on a more advanced configuration, and we'll be configuring an HTTPS virtual service. So stay tuned and look forward to our next session.